Today we're going to learn how to graph polynomials. And all polynomials look something like this. Like that, or maybe like this. Or this. They all are like that. You start drawing things like this, they're not polynomials. Nice and smooth. Nice and smooth. Those are examples of what polynomials look like. So, how do we graph them? The answer is we find out when they equal 0. The zeros. 1, 2, 3, 4. Fact is, 7 is never 0. Some people may say, oh, come on, when x is negative 7, 7 is equal to 0? Of course not. 7 does not equal 0, ever. Doesn't happen. So, 7 is never 0. If you have a number and you take away 2 and you get 0, that number is 2. 2 minus 2 is 0. If you subtract two numbers and you get 0, immediately say those two numbers are equal to one another. You may say, well, x is not a number. Of course it is. In this case, it's 2. X is the placeholder for a number. X plus 3 equals 0. Well, you learned additive inverses. If you add two numbers and you get 0, the two numbers have different signs. Since that 3 doesn't have a sign, it's understood to be positive 3. So the other number is negative 3. One number plus negative 9 is 0. These two numbers should just differ in sign. In signs. That number is negative 9, so that number is positive 9. That's what additive inverses are all about. So, if you have an unknown number and you add 1, which is understood to be positive 1, and you get 0, that's because the other number is negative 1. Okay. So, when x is 2, you'll have 7 times 0 times, it doesn't matter, you're gonna get 0. When x is negative 3, that'll be 7, that'll be negative 5, that one will be 0, and that will be negative 2. You're gonna get 0. Y is gonna be 0 when any one of those factors is 0. And so these are the zeros. Now, no other 0 would work. Like x equals 11. 7 is not 0. 11 minus 2 is not 0. 11 plus 3 is 14. That's not 0. 11 plus 1 is 12. That's not 0. So, when you multiply all those zeros together, non-zero numbers together, you're going to get a non-zero number. So, 11 can't make it 0. Only numbers that make the 0, one or more of those 0, will make the whole product 0. Okay. So, we know some of the zeros. We know all of the zeros. 2, -1, and -3 are all zeros. So either the graph goes like that, or the mirror image. The graph goes like that. Now, you can plug in 0 for x. You'll get 7 times -2. 0 plus 3 is 3. 0 plus 1 is 1. And all that really matters is that you'll get a negative number. You'll get -42. And there it is. It's the blue graph. But I don't like doing it that way. Especially if x equals 0 is a 0. Okay. In the blue graph, when x is really large, this graph is taken off. In the pink graph, when x is really large, it's very negative. So think of x large. 7 is positive. A really large number minus 2 is positive. A really large number plus 3 is positive. And a really, really large number plus 1 is positive. It is going to be positive. So the answer is the blue graph. When you are in calculus, you will be able to find that low point. You'll be able to find that high point. But for the record, you can find the y-intercept every time you're on the y-intercept and you happen to look up to the x-axis. There's the number 0. X is 0. We actually had these numbers up here a moment ago. So, if x is 0, y is equal to 7 times -2 times 3 times 1, which is -42. So that value is -42. And there's your graph. If I were you, I would not number my number line. Because at least don't do it until you find out that this distance is 42. Because if you go 1, 2, 3, 4, 5, 40, positive 42 is going to be way up there. 42 is really long from 0. -42 isn't the same length. Don't number your number line. At least don't put many numbers on. There's your graph. Let us try to do another one. Trick here is to find the zeros. Suppose y is -3 times x minus 2 times 3 minus x times 4 minus x. The zeros. -3 is never 0. That factor is 0 when x is 2. 3 minus 3 is 0. So x is 3. And 4 minus 4 is 0. Those are the zeros. 2, 3, and 4. Okay? Well, let's call that 1. 1, 2, 3, 4. 1, 2, 3, 4. 2 is the 0, 3 is the 0, and 4 is the 0. When x is really large, that number is negative. A really large number minus 2 is positive. 3 minus a really, really large number is negative. 4 minus a billion is negative. When you multiply those signs, you get positive. That means when x is really large, I'm above the x-axis. And I just want to move 4 a little bit over. Okay, so the graph comes down, it touches at 4, it touches at 3, and it touches at 2. Don't let it touch elsewhere. And there's your graph. Again, it's something like that. I promised you it'd be like that. Let us try to draw some more. Y is equal to negative 2 times 2x minus 3 times 7 minus 2x times x plus 3. Let us find the zeros. This is never 0. 2x minus 3 is 0. Well, like I told you, if you subtract two things and you get 0, equate the two things. 2x must be 3. Otherwise, when you take away 3, you won't get 0. So x is 3/2. That's this one. If 7 minus 2x is 0, these quantities are equal. 2x is 7, so x is 7 over 2. X plus 3 is 0. Additive inverses. This 3 is understood to be positive 3, so x should be negative 3. Okay, let me get rid of this side work so we can draw the diagram. So 1, 2, 3, 4. 1, 2, 3, 4. Negative 1, negative 2, negative 3. Well, it crosses at negative 3. 7 over 2 is 3.5. 2 goes into 7 3 times. What's one left over? 3.5. 3 over 2 is 1.5. So we have a 0 at 1.5, and at 3.5, and at negative 3. So once again, we don't know if the graph goes like this, at least not yet. Does it go like that? Or is it the green graph? Well, remember, over here, when x is getting larger and larger, the y value is going down. It's getting more and more negative. Here, as x gets larger and larger, so is y. So when x is large, the first factor is negative. It's always negative. 2 times a large number is really large. And when you take away 3, it's still large. That means positive. 2x is a really large number. 7 minus a really large number is negative. A large number plus 3 is positive. If you were to multiply those 4 signs, you will get a positive. If you have an even number of negatives, we have 2 negatives, and 2 is even, you'll get a positive answer, and it's the yellow graph. The y graph, the green graph, I meant to say, doesn't belong there. Now, I want to look at a nice easy problem. Suppose I tell you that y is equal to x minus 1 times x minus 3 times x plus 2. The zeros are 1, 3, additive inverses tells me x is negative 2. So at 1 we have a 0, and at 3 we have a 0, and at negative 2 we have a 0. Now, if x is anywhere near 1, this sign will not change. If you're about 1, a little more, a little less, and you take away 3, you're negative. If you're about 1 and you add 3, you'll be about 4. Not near 0. The other one, you'll be around 1 and you take away 3, you'll be around negative 2. But here, if you're a little bit more than 1, if x is a little bit more than 1, let's denote that by 1 plus, and you take away 1, you'll be positive. You have more than $1, and you take away $1, you're positive. You have a little left over. If you're a little bit less than 1, you can't spend $1, because if you did, you'll be negative. The sign changes at 1, only for one factor, the factor x minus 1. When x is near 3, if you're around 3 and you take away 1, you're around 2. You're nowhere near 0. You'll always be positive. If you are around 3 and you add 2, you're around 5. Nowhere near 0. But if you have a little bit more than 3 and you take away 3, you'll be positive. If you have a little less than $3 and the store lets you buy something for $3, you owe them some money. You're negative. The sign only changes at 3. Similarly, the sign only changes when x is, let me say that a little bit more careful. The sign changes when x is around 3. A little bit more than 3, a little bit less than 3. This value will be different. If x is a little bit more than 3, x minus 3 will be positive. If x is a little bit less than 3, or a lot less than 3, and you take away 3, you'll be negative. Okay, so x minus 1. This is the only factor that's gonna change signs at 1. And I have the zeros, and when x is really large number minus 1 is positive, large number minus 3 is positive, large number plus 2 is even larger, positive. You multiply those two, you get positive. So here is your graph. Now obviously, there's a reason we just talked about that. Suppose you were asked to graph y is equal to x minus 2 squared times x minus 4 cubed times x plus 2 to the 5th. There's zeros. Remember, 0 squared is 0, and only 0 raised to the 2nd is 0. Only 0 cubed is 0. Only 0 to the 5th is 0. That is, those powers will not affect the zeros. Just ignore the factor. When is the base 0? When x is 2. When is this base 0? When x is 4. When is this base 0? When x is negative 2. So we have the zeros. Negative 2, positive 2 the number 4. And when x is really large, well, when you square, it's going to still be positive. If you're really large and you take away 4, you'll be positive. If you cube a positive number, you'll get a positive. If you're really large and you add 2, you're a positive number. And a positive number times itself 5 times is positive. So the result is positive. But here's the thing. Let us look more carefully at x minus 2. If you have a little bit more than 2 and you take away 2, you'll be a positive number. If you're a little bit less than 2, like 1.9 or 1.99, and you take away 2, you'll be negative. But we're squaring it. What's in here is positive. And when you square it, it's still positive. What's in here is negative. And when you square a negative, you get positive. That is, when x is around 2, the sign doesn't change because that power is even. If x is around 4, let's look at x minus 4 to a odd power. If x is a little bit more than 4, and you take away 4, that will be positive. If you're a little bit less than 4, and you take away 4, you'll be negative. But we need to cube this. And you know what? When you cube a positive, it's still positive. And when you cube a negative, you'll be multiplying 3 negatives together. An odd number is going to be odd. That is, cubing didn't do anything. And when you raise to the 5th, it won't matter. If you're positive and you raise to the 5th, you're still positive. If you're negative and you get raised to the 5th, you'll be negative. If the powers are odd, the sign changes at 4 and negative 2. Now, let's go back to the last graph. If you notice, around 1, when x is a little bit less than 1, I'm positive, and when x is a little bit more than 1, I'm negative. Little bit less than 3, I'm negative. Little bit more than 3, I'm positive. Doesn't matter. It isn't always if you're a little bit more, you're going to be positive. No. Here, this number is larger than this number. And the graph is positive, and here the graph is negative. This number here is larger than this number. But now, the larger is negative and the smaller number is positive. All I'm saying is the sign changes near 1, near 3, and near negative 2. So, what we know here is the sign will not change at 2. Well, what makes the sign change at 2? If you go from negative to positive, or you go from positive to negative. Well, we won't do that. We will not cross that yellow line. When x was large, we were up here. Maybe at 2, I'll put an x, because it's an even power, and I won't cross it. I'll just touch it. Because y does equal 0 at 2. There's your graph. Told you. You're just going to draw things like that. You cross at -2, you cross at 4, but you only touch at 2 because it's an even power. Odd powers, you're gonna change signs. Can't stress that enough. Okay. Let's try another one. Suppose you have y is -3 times 2 minus x cubed times 3 plus x squared times 1 plus 2x to the 4th times 3 minus 4x to the 5th. There's zeros. -3 is never 0. This base is 0 when x is 2. This base is 0. Oh, I'm adding and I'm getting 0. That means these two numbers have different signs. That 3 is understood to be positive. The x is -3. 1 plus 2x is 0. That means these two numbers have opposite signs. The 2x is not 1 because that's 1. It must be -1. Divide by 2, you get -1/2. This one, 3 minus 4x is 0. You subtract and you get 0. Your habit needs to be to immediately write down those two expressions and put a horizontal line between them because they are equal. Divide by 4, we get 3/4. Okay, let's get rid of our side work. I want you to see the graph in front of us. You have 1, 2, 3, -1, -2, -3. Two is right here. -3 is right here. -1/2 is in between 0 and -1. And 3/4 is right here. Okay. Now, the ones that have a positive x, an even exponent, I won't cross. That was when x is -3. I will not cross there. This is when x was -1/2. I will not cross there. Okay. If x is very, very large, -3 is negative. 2 minus a large, large number will be negative. And if you cube it, it'll stay negative. This one, I don't care what the base is going to be when x is large, because once we square it, it's going to be positive. Once we raise it to the 4th power, it's going to be positive. 4 times a very large number will be very large. And 3 minus a large number, well, that's going to be negative. To an odd power, it still stays negative. 1, 2, 3 negative, it's negative. That means the graph comes like this. It comes back down. It only goes up to touch at 1/2, just a touch. Comes down, goes back up to touch -3. Like I said, all we're doing is drawing things like that. And that is the graph. Again, the only thing that we may not have right is maybe this should have gone a lot lower. Maybe this shouldn't have gone as low. Maybe this should have gone a lot higher. You'll learn that in calculus. Nobody's going to mark you wrong if you don't go down far enough yet. Just don't not care about those things when you're in calculus. So now I'm going to give you 4 graphs and 4 equations, and we're going to try to match them up. -2, 1, 1, 2. That's the first graph. The second graph goes like this. The third graph goes like that. -2, -1, 1, and 2. And the last graph goes like that, and it crosses the origin. Okay, this is 1, that's 2. This is -1. And here's -2. And the so those are the 4 graphs. And the 4 equations are y is equal to x times x squared minus 4. Y is 1/2 x to the 6th minus 2x to the 4th. Y is -x squared times x squared minus 4. And y is -x to the 5th plus 5x cubed minus 4x. Let us look at the first one. It's x times x squared minus 4. You can't do anything to the x, but if you think of 4 as 2 squared, well, there's the x. Now I'm going to factor this. X is being squared and 2 is being squared. And you have that necessary minus sign in between. So you write the 2 things being squared 2 times. One gets a plus, one gets a minus. And now the zeros will be when x is 0, when x is -2, and when x is 2. So I would look to see which graphs have those 3 zeros, and hopefully it's only one of them. This graph has a 0 and -2, and at 0 and at 2. Ooh, so does this one. And it's the only zeros it has. Ooh, so does this one. Only -2, 0, and 2. But the other one, yep, it has zeros at -2, 0, and 2. But it also has 2 other zeros. So we know this one is not right. So we need to figure out what it can be. Now, notice that the graph just touched at 0. That is, you should have x to a even power. Ah, shucks, we don't have x to a even power. Likewise over here, it just touches, like that factor came from x minus -2, which made it x plus 2. This factor came from x minus that number. And this factor came from x minus 0, which is 0. But it just touches, so it gets squared. Same thing with this one. Up into a constant. I don't know what constant to put in front. But this one's going to be the same. Going to be a constant times x minus that number, which becomes x plus 2, times x minus that number, times, x minus 0, which is x, to an even power. This one, you have y is equal to a constant times x minus that one, times x minus that one, times, it crosses, so x to an odd power. But that's exactly what this one is. Okay, we factored it. This constant that I'm talking about happens to just be the number 1. Could have been another number. Okay, so this here is a graph of x times this, which is x squared minus 4. Okay. So now let's see what we can do with the second one. Since I'm numbering them, let me number them. Y is equal to 1/2 x to the 6th minus 2x to the 4th. Maybe I'll factor out the half. And this has 6x's being multiplied by itself, and this has 4. So they only have 4 in common. A half times 1 is a half. X to the 4th times x squared gives me x to the 6th. Minus half of 4 gives me the 2. And then I have the x to the 4th here. If you want, you can multiply by 1, but I wouldn't. Okay. So this is 1/2 x to the 4th times this. Well, we just factored that. That's x plus 2 times x minus 2. Now, if you ask me to graph this, I would say, the zeros are 0, but it's an even power, so I won't cross it. -2 and +2. And when x is really large, a half is positive. X to an even power is always positive. Large plus 2 is positive. Very large minus 2 is positive. It's positive. So it's up here. It comes down and it crosses at 2. It touches at 0 and it crosses at -2. That obviously is this graph. So this is graph number 2. This is graph number 1. Now let us look at the third one. Y is -x squared times x squared minus 4, which is 2 squared. If you have a number squared minus another number squared, you add the two numbers and then you subtract the two numbers. So there's the -x squared here, and over here, it's the difference of squares. I add the two numbers being squared, I subtract the two numbers being squared. The zeros are when that's 0, when that's at 0, when this is 0, which is negative 2, and when that's 0, which is positive 2, only this one has an even power, so I won't cross there. When x is very large, x squared will be very positive. But somebody went and put a negative sign in front of that positive number. Large plus 2 is positive. Very large minus 2 is positive. It's negative. Okay. So I start negative. I cross. Oops. I cross. I touch. And I cross. Y-axis. X-axis. And that's this graph over here. Process of elimination says that's graph number 4. But let us look at it. Let's make sure. On an exam, that's number 4. Y is negative, well, it's in front of me. So, what all of these terms have in common, like the first term is negative x times x times x 5 times, plus 5 times x times x times x, minus 4 times x. They all have one x in common. So I factor it out. In fact, I'll even factor out negative x. Negative x times x to the 4th is negative x to the 5th. A negative times a negative gives me a positive, times 5. To get x cubed, I multiply the x by x squared, plus 4. Okay, now this here is a, what's in the brackets is a quadratic equation. I mean, if we let u equal x squared, well then u squared will be x squared squared, which is x to the 4th. So that's u squared minus 5u plus 4. And I want to know when it's 0. Two numbers that multiply out to negative 4 but add up to negative 5 are those two numbers. So it's going to be u minus 4 times u minus 1 is 0. That means u is 4, u is 1. But u is x squared. If x squared is 4, then x is plus minus 1. And if x squared is 1, x is plus minus 1. If you have a quadratic that is the highest power is 2, there might be 2 zeros. And this factor is 0 when x is 0. Okay? And that should be plus minus 2. I think I said that. So here we have 6 zeros. And when we factored it, they were all linear. That is no second power. So, well, we're going to cross at 0. We're going to cross at plus minus 2, 2, and minus 2. And we're going to cross at plus minus 1. Okay. Now, I guess I labeled this wrong. I apologize. Negative 1 and 1. They cross there. And when x is really large, when x is really positively large, this is going to dominate. Negative, a really large number. 10 to the 500. Raised to the 5th. This is 1,000. You know, let me do it a little bit differently. Suppose I say that x is 10 to the 100. So it's negative x to the 5th plus 5 times x cubed minus 4 times x. Okay. This is negative 10 to the 500 minus 5 times 10 to the 300 minus 4 times 10 to the 100. Let me not complain that I'm running out of room. That number, I don't really care so much that it's negative, but it's negative 1 followed by 500 zeros. There are 500 zeros there. And here we have 5 times 1 followed by 300 zeros. This number versus this number, which is really going to have a 5 here. You're going to have 1 and then 200 zeros. 200 zeros. And then you're going to have 5 by 300 zeros. Okay, so this is one number. I just added them. Okay? This 5 is insignificant. If somebody owed you this amount of money, but they only paid you with a 0 here. Now I admit, 5 followed by 300 zeros. That's a serious amount of money. But it's nowhere near 1 followed by 300 zeros. This x to the 5th term dominates. And when x is very large, you have a large raised to the 5th, which is large. But then you put a minus sign in front of it. It's negatively large. So it's down here. It crosses at 2, it crosses at 1, it crosses at 0, crosses at negative 1, and then it crossed at 2. As I told you, it's going to look something like that. Okay, that completes this section on polynomials and their graphs.